Okay, we're going to finish our foldable, I hope, today. So here's the stuff we already did. And we talked about completing the square, which was the part that was confusing me. So I hope practicing in class helped you. Okay, so I'm going to try really hard to make this work. I think I did too much work yesterday. And I'm going to try to think about what I'm doing and find the easy way to use these different forms. If I have vertex form, I know my vertex. My vertex is 1, -7. The negative in front of the 1 is part of the equation, does not go with the 1. So 1, -7 is my vertex. And I also know that x equals 1 is my axis of symmetry because it's a 1. I know, just FYI, that because my A term is positive, that it's going to be concave up. It's going to have a minimum. And it's going to look like that. All right, so if I go down to my graph and see how that works. So I go down to my graph and I plot 1, -7. It's going to be right there, which is good for my going up minimum. Okay, my axis of symmetry is my -1. Is it -1? Oh, I just did that all wrong, didn't I? Dang. Okay, let's just erase that and try that again. So 1, -7, it would be over here, and my axis of symmetry would be right here. That's much better. Okay, so I'm taking 2 points, my 2 and my 3. I'm going to substitute them into my equation and solve for y. So my first one's going to be 2 minus 1, which is 1 squared, minus 7 is -6. So 2 -6 is a point. And then I'm going to put in a 3. 3 minus 1 is 2. So I have 2 squared, 4 minus 7, which is -3. So I have 2 -6 is a point, and 3 -3 is a point. And since it's mirrored, I can do a -6 over here and a -3 over here. And hopefully you can see the parabola is going to look kind of like that. Okay, standard form. Pause the video and try it if you want. If you're watching the video, if you're not watching the video, you're not listening to me, so it doesn't matter. Okay, so here's what I know. I do know that because this is negative, it's going to go down, concave down. It's going to have a maximum. It's going to look like that. I don't know my axis of symmetry yet, but I know that I can do that negative b over 2a. So I'm going to have -2 over 2 times -1, -1/2 times 2. So -1/2 times 2 is -2, and my b is -2. So I have 2 over -2, which makes -1. So that's not right. Yeah, it is. No, it's not. Because 1/2 of 2 is 1. So it's 2 over -1, so it's -2. So -2 is my axis of symmetry. If -2 is my axis of symmetry, then I know that the x value of my vertex is -2. So I can substitute -2 into my equation to find my y value of my vertex. So if I do that, I end up with -1/2 times 4, that'd be -2 squared, minus 2 times -2, which is +4 plus 1. So 1/2 of 4 negative would be -2 plus 4 plus 1, and that would be 3. So my vertex is -2, 3. So I can plot that on my graph, negative 2, 3. It's going to be up there. Remember I said it's going to go down, so that's good. Okay, here's my axis of symmetry. So if I put 0 in, I'm going to fill in my table. Then that's really great because I know y equals 1 because it's 0 plus 0 plus 1. And if I put 2 in, I get negative 1/2 of 4, which is negative 2. And 2 times 2, negative 2 times 2 is negative 4 plus 1. So I have negative 6 plus 1 is negative 5. So I have a point at 0, 1. And I could put a mirroring point on the other side. I have 2 and negative 5. And so I can go 2 more and be at negative 5. And hopefully you can see the concave shape down. And that is my minimum. So the only place where there's really extra work is right here if you have standard form. Okay. Onward. Multiple representations, just like with lines. We did this before. We could do a table, mapping, a graph. So here's our equation. And okay, it's time for lazy. You ready for lazy? Or I could just copy from my thing. I'm going to go ahead and show you lazy. Okay, so here is my graphing calculator on my screen. What? It's awesome. Okay, so here's what I'm going to do. Remember how we put in equations and then went to second graph and looked at the table? So I'm going to go to y equals. I'm going to turn off my plot because we're not doing that right now, although we might in a minute. I'm going to put in, ooh, first I have to solve, don't I? Dang. Let's go back over here. Okay, first I have to solve this. This is not ready to go, is it? I have to add negative 2x to, I have to add 2x to both sides, 2x squared. So I end up with y equals 2x squared plus 8x minus 3. Yeah, because otherwise it doesn't go in there, does it? Okay. So I have 2x, here I am, 2x squared plus 8x plus 8x minus 3. I go to second graph. Looking at my y1 values, I'm going to find the ones that are already in my table. Negative 4. Okay, so negative 4 is negative 3. Negative 3 is negative 9. Negative 2 is negative 11. Negative 1 is negative 9. And 0 is negative 3. So let's go back to our table and put in negative 3, negative 9, negative 11, negative 9, and negative 3. So there's my table. Okay, so my map, remember I have my two thingers, and I have x and y. And remember we don't duplicate numbers, and we put them from smallest to biggest. So I have negative 4, negative 3, negative 2, negative 1, 0. And my smallest y value is negative 11, negative 9, and negative 3. And they repeat, so I only write them one time. Negative 4 goes with negative 3. Negative 3 goes with negative 9. Negative 2 goes with negative 11. Negative 1 goes with negative 9 also. And 0 goes with negative 3 also. My domain is all real numbers. And I don't know what my range is. I suspect, but okay, so let's plot those points. Negative 4, negative 3. I can't see very well. Negative 3, negative 9. Negative 1, negative 2, negative 11. Negative 1, negative 9. Okay, pretty sure that's going to be my vertex. So there's my graph. So my range is going to be y greater than or equal to negative 11, because that's the lowest point. Everything else for y is going to be greater than that. Okay, so let's look at how you tell the difference between linear and quadratic. If you have, and I'm just going to make up some number. I'm not making up numbers, but I am. If you have something that looks like this, and we talked about this before, these are going up by 1, right? And these are going up by 3, 3. If this is constant, it's a line. Compared to, and most of them won't be this easy to see, but we'll start out easy. 4, 7, 12, 19, 28, 39. Okay, so if you look at the differences of these, this difference is 3, this difference is 5, this difference is 7, this difference is 9, this difference is 11. Okay, it's changing, so it can't be linear. And if you look at this is called the second difference. If you look at the second difference, you'll notice though that they're all the same. So if the second difference is the same, then it's a quadratic. And if those were still changing, then it would not be a quadratic. We'd have to move on to another option. Okay, we can always graph those in the calculator and see which one fits best and what it looks like. So, oops, last one. If you notice your x values are going up, increasing, your y values are decreasing, and then all of a sudden they start increasing. So x decreases and then increases. If it changes directions, it's a quadratic. So when y changes directions, it's a quadratic. I hope yours looks neater than mine. Okay. So it's you're either going to see the second difference, or you're going to see a change in your y values descending and then ascending, or ascending and descending. Those are the two ways you can tell, or you can graph it. We're going to do that in a minute. Actually, we're going to do that right now. Okay. So, because we're going to, may as well. Okay. Let's go ahead and go back to our graphing calculator, and you have yours somewhere. And I'm going to have to pause. Dang it. Dang it, dang it, dang it. I thought I could. All right, I'm going to finish later. So